Okay, now we're ready to start working on a table. That's coming up next out of aluminum, out of 3-inch stock, and probably about maybe 3/4 inch in width, and that's coming up next. I have duct tape around the jaws here as a safety precaution. The jaws are almost all the way out as far as they can go to grip this here at 3 inches. And so just by putting this duct tape around here, it ensures that the jaws will stay in their respective places. Okay, all this here is high up through here. When I get down to this low side right here, that's the low side. I have a black mark there. That's about 810 thousandths from the surface plate up, so there's a thickness of 810 thousandths. I have a black mark right here, and then what that means is that whenever I hit the black mark here on my lathe, then I'll know that I'm at 810 thousandths, and then I can set my dial indicator on my lathe to the 750 that I need, and then that will be set for both pieces. Okay, I'm not quite there yet, but I'm very close to it. Okay, I'm wearing away that reference mark a little bit more at a time here, so it's not going to be much more before I have that completely down. Okay, I checked this and I'm at 790 now, so I have 40 thousandths to go. And so now I have my dial indicator set up, and now I'm going to go ahead and take that 40 thousandths on the dial indicator, and then I will be ready to set my stop here. And then this will be ready now to go down to the 3/4 inch dimension. And then once I get that set there, the stop being set right here, then it will allow me to take the next piece and do the same thing, get down to the same size. Okay, I'm at about 748, I think, around here. 748, that's good enough, close enough to 3/4. Alrighty. Okay, when I first took it off the saw, it was cut a little bit, not perfectly flat or square. And when I did the first face, I just put the sawed end tight against the jaws in the back side here, and I machined the first side. Then I turned it around and then paralleled the second side with the first side. But because the first side was already, originally it was caulked a little bit, means that it's going to take it a little bit out of round as well. And so now both sides are now parallel with each other to the perfect thickness that I'm looking for. But because, again, like I said, because it was caulked in the jaws to start out with, there's going to be some out of round going on here. And that's what I'm getting. I'm getting about 70 thousandths of a bounce here. And so what I'm going to do is just take this down now in the diameter to get rid of the oblongness now, which is about 70 thousandths. And then once I get that taken care of, then everything will now be, again, it'll be flat, and it will be then in perfect round it needs to be. So that's coming up next. Okay, there's one little spot right here yet, from here to here. Okay, I took care of that one side. I'll flip it around to the other side now. Okay, I just flipped it end for end now. And I put just a dial indicator real quick here, just to see how much that's staying steady there. And because we machined this here to be flat with this side here, I have this now tight against the chuck jaws here, as tight as I can get it. And just giving a good double check here to make sure it is staying parallel with each other. And so that looks good. And so now we're ready to machine this down now to get it to the proper diameter to match this. Okay, now I'm looking down to that black stripe. Okay, they're totally concentric now, both on the face and the diameter. Both faces are parallel with each other. That indicates right here. And this diameter, this is the diameter here that it's now running concentric. Both dial indicators are showing no real heavy movement or anything. Nice and steady. So the workpiece is now concentric all around. Okay, what we have still in the lathe, we'll just go ahead and drill and tap this for 1/2 inch 20 so that it'll match the mating threads on the column that we made earlier. Alright. Okay, now we'll try the column, see how that fits in there. Alright, happy with that. Okay, let's get a preliminary. Got 3 bearings on top of there. And then we got the stop down here, we can tighten it up, loosen it, and spin it. Alright. That'll work. Okay, now it's time to do the features on the table here. But before I do any of these here features here, I need to hollow out the bottom side of the table. And that will be in these 4 quadrants right here. I will leave this solid down through here so I can put the T-slots in. And then the rest of it here will be hollowed out and probably to a maybe 1/8 of an inch, maybe 1/4 of an inch in thickness in these 4 quadrants. And I need to get all this set up now on my rotary table. That's coming up next. Okay, I think the first thing in order is to make a arbor that I can screw this thing down to, that I can put on my rotary table. And underneath here I've got a bunch of wooden faceplates made. I'll take one of these and I'll make an arbor that I can fasten to the wooden faceplate, screw this down onto there, and then put a capture nut on there, and then fasten the wooden jig to the rotary table. That's coming up next, making an arbor for this. It'll look something like this here. It will be a flange on the bottom that will screw to the wooden base. Then it'll be a threaded stud here to capture the capture nut on top as well as the workpiece, and then the smooth area here, a little bit of a jog out there that would be good for use for indicating in on the rotary table. And I'll thread that to 1/2-20. Okay, 366 thou. That'll allow me to put my put that in my milling machine. I'll be able to put that in the chuck jaws, 3/8 inch chuck jaws, and then I can also use this to indicate in for the rotary table. Okay, there's the fixture I got made so far. What I did was I threaded the back side of this 1/4-20 and then put a 1/4-20 bolt through there. And now everything's nice and tight. It's sandwiched together nice and tight. And then I can put the workpiece on here. And what I can do is I can drop this onto the rotary table. So I'll show you the sequence now of how I'm going to set this up now to do the milling for the table features. First, I get the center of the rotary table centered up with a spindle, indicating that in. Next, I get this in this spindle here, putting in the jaws, chuck jaws, line the notches up, and lower it down. And next I'll put the bolts in. Finally put the bolts in. And I'll get this tightened down. Get this down all the way. And I'll tighten these down now, and I'll be all set up. Now I'll loosen the chuck jaws. Bring it up. Put our workpiece on. Get that nice and tight. Okay, I'll see if I can explain now what I'm trying to do here. This is a table with the features on it. These are the T-slots, and these are those there through-hole slots that's on the table. This represents the rim, which is about 1/8 of an inch in thickness. Now the first thing I want to do is I want to hollow out the back side in all 4 of these quadrants. Now in order to do that, I have this here just screwed down to here. On here, it's captured down here nice and tight. But what I want to do first of all is I want to secure these dimensions, and I want to drill a hole in each one of these areas right here, which is 1 inch, 119 thousandths from the center. And that way there I can put screws in there to secure the workpiece. When I get this secured in 4 quadrants here, then I shall be able to rotate the rotary table and start working in between here and here. That's going to require coming over on the x-axis or y-axis, whichever I choose to use, to get that established. But before I even do any of that there, I need to start here and get these holes drilled so I can have a way of securing the workpiece to the jig, to the fixture. Now I'm going to do is I'm going to zero my rotary table. I will zero that, and then I will be able to have everything established on the zeros here, and then I will rotate it 45 degrees on the rotary table, and that will allow me to make the first hole. And then I'll keep on going every 90 degrees and drill a hole, and then that will establish the secure points for the screws. Okay, I'll use drywall screws for the fixture screws. Okay, I need to move my table 1.119 inches. That will get me the radius out for these here holes being drilled. But I think the first thing I want to do is, while I have it set up here in this direction here, I'm not going to move my y-axis because I only have a 1 inch indicator here, and I got to go over an inch by 119 thousandths of an inch more. So my x-axis indicator here goes for 2 inches, so I got enough here to work with. So I'm going to use my x-axis to move the travel the table. So what I'm going to do, the first thing I'm going to do is make sure this is nice and tight here, won't move on me. And I'm going to move this 1 inch, 119, and then I'm going to keep everything locked here on 0, and I'm going to make a mark here, and that's going to indicate the 0 reference. Then I will turn my rotary table 45 degrees, and then I'll start doing my drilling for the secure holes to secure this down tight to the fixture. One inch, 110, 19 thousandths. Alright. So I'll drill this hole here as my 0 reference. And just a quick reference check to make sure that we're lining up here, which we are. 1 inch, 119. Okay, that's good. Okay, now just for a quick verification here. My total diameter of the workpiece is 2.920. I divide that by 2, and that will give me 1.46, which is the radius from here to the outside edge. I subtract that 1.119 to get me to this, and that will give me the distance from here to here. So minus 1.119 equals 0.341. And when I do check this at 0.341 on the dial calipers, and I put this here tangent on here, it is going through the center of the reference mark we made here, as I put that tangent to the outside of the workpiece here. So that's just a quick verification. I like to double check, even triple check before I continue on, and everything checks out. So that's ready to now start drilling the holes for secure points. Okay, I now turn this to 45 degrees in this direction here. 20, 30, 45 degrees. And I am now ready to start drilling for the secure points. Okay, now it's time to move to 135 degrees, which is 90 degrees past the 45 here. So 135 degrees, and we'll start drilling the next one now for secure point. Okay, now 225 degrees. And so on. Okay, and last, 315. Okay, that takes care of all secure points. Now back to 0 again. And now I'm ready to start getting the next dimensions. That will be to do the interior quadrants, the milling out milling out these quadrants to give them these here hollow features in between here. Okay, I need to make a correction on what I said before. This here mark right here, the first mark I made, is the 0 indicating on the rotary table. And what that is the 0 on the rotary table that indicates that this is the center of the T slots. The T slots are the ones that are going to be referenced off of. So the T slot starts here and of course 90 degrees across. So this is the 0 mark for the T slot. That means then that all of the machining is in between the two T slots. So in this case it would be here and here. So what I would do is I take out this one screw here, and these 3 screws here now will give me the support I need for me to machine in between the two T slots. And that will be hollowing all that out to give that there hollow feature on the bottom side of the table here. Once that's accomplished, then I will put the screw back, well, then I would leave that screw out, and then I would move over to the next one, and then I would have to just keep on working back and forth until I get them all hollowed out. I'll probably have to use a smaller screw once I get this hollowed out in between here to hold, if I have to use one of the hollows to hold it. So that'll be later on when I get down that road there. But right now it's a matter of getting things set up now to find out how much I need to move my y-axis over now in order to start machining the features that go along this T-slot. What I'm actually going to do now is I'm going to machine the T-slot areas where the T-slots will be located later on from the top side, so that I can go in between these features to do the hollowing out. So that's what's coming up next now, is to get secure some dimensions here, and to get the table set up in the right direction and everything, and get everything going here to do the actual milling out now. Explain it here. These here lines right here represent the T-slots. They're going to be solid all the way through. It's this area here where the through slots go through, and I used one screw here in one of the through slots for security at this time. But it's between the T-slots here that is going to be milled out. From here down, be like a little rim, and over here. And all this will be hollowed out, so that when I, later on from the top of the table, when I do the T-slots, I'll be able to do the through-hole slots as well. But this here is where I need to do now, is all the hollowing out in between here. Okay, now it's time to do the hollowing out on the back side of the table. And what I realized is when I was putting the table back in position under the spindle, that I was a little bit out of center here. And as I checked over this a few times here, I realized that the fixture itself is not centered perfectly on the rotary table. It's up about maybe 27 thousandths. And that's the result of putting this part here in the Jacob's chuck and then bringing it down until it tights to the rotary table and then tighten the bolts down. And it could have moved a little bit here and there because I had the rotary table 0 indicated improperly. It's just that the fixture itself is just a little bit off center of the rotary table. So instead of indicating in on this little small area here, what's more important is the actual workpiece. That's what's going to be where the features are going to be milled in at. So I need to have these features here milled in, and I need precision in this area here now with this rim. And so that's why instead of indicating off of here, I'm going to indicate right off the workpiece here. And I'll show you how much this is a little bit around. What I'll do is I'll turn the rotary table, and I will see how much that's out around. See how that gauge is moving back like that. So it goes to about 27 thousandths and then comes back in again. So all I got to do is loosen these here attachment bolts here, and then just tap it over, watching the gauge until I get 0 as I turn the rotary table all the way around. When I'm hitting 0 on the indicator here, then I know then that this is indicated in with the whole fixture and everything indicated in properly on center with the rotary table. And that's what I'm going to do next here now. Okay, I'll get you on the side here where you can see what I'm doing here. What I'm going to do is I'm going to turn the rotary table. I'm watching the dial gauge here, and I'm going to be tapping on the fixture itself as I 0 indicate this in. So right now I'm hitting a little bit high now as I'm coming across here, so I'll go as far as it goes before it drops back again. So that's pretty much on the high there. It's probably bottomed out right now a little bit. Okay, so now it's starting to come down. So what I'll do, I'll just tap this over now a little bit, about half of that for right now for starters. Let's get a little bit finger tight here. Finger tight here. Put that back on 0 again here. And start taking it around again. Okay, so now it's dropping down. So I'm going to come this way a little bit now. Back up. And now we're very, very close to staying. Now let's see what it's doing. Now it's going higher again. So let's tap it a little bit now. I don't want to tap it all the way to 0 because I have to, I don't want to overshoot it, so I'll just keep on hitting this until she's staying at 0. I'll just keep on working that until I get that. That's what I'm trying to do now to get it zeroed in. Okay, I got it all adjusted in here now. Just show you a little bit here. See how the dial, as I move the rotary table now, how the dial is pretty much pegged now, pretty close to 0 there. It's maybe about 1.5, 2 thousandths in this area here. It goes up, and then she drops back down to 0. And I had it at 0 all the way around, but then when I go to tighten these bolts here down, it has a tendency to kind of like throw it off kilter a little bit. But I'm satisfied with about 2 thousandths of an inch. That's not bad at all. At least we're pegged now. At least it's not moving constantly, and that's the main thing. And now I'm back to 0 on my rotary table, and everything's staying pretty well stable here. So now the workpiece is now finally centered within 2 thousandths. It's really centered pretty well now on the rotary table. So now what I can do is I can center the rotary table, which would be this part right here now, back under the spindle. And I can also do my edge finding off of here. I can do all kinds of references off the workpiece itself now that it's actually on center of the rotary table. That's the main thing for the workpiece, to be on center of the rotary table, and everything else will then fall into place when it comes to putting the features in with the dimensions and everything, because now I can work off of the edges of the workpiece itself. Okay, so now it's time to start getting things set up here to do the hollowing out now on the mill table here, and that's what's coming up next. Okay, now where I have my workpiece at, this here little mark right here, that indicates the center of the T-slot. And that would be right here, that would be. Okay, I have my spindle here right now in the center of the workpiece. I now need to machine this kind of a section here now. So what I will do is I will take, since I'm on the center of my T-slot here, I will take this dimension right here. I will take half that dimension, and that will give me out to this line here, which is the border line there for the T-slot, the interior part of it. Then I have another 55 thousandths to go before I actually get into the line where I'm going to actually start doing the cutting. And then I will move again 1/2 the diameter of my cutter bit, so I can end up with the edge of my cutter bit right on this line here. So I need to get these here dimensions secured here, and then I will move my y-axis. I'll move my y-axis on my table this direction so that I can put my bit over on this side here, and I'll do my straight cut all the way down. And then what I'll do is I'll drill first here, come down here, drill, and then I will do the same thing all the way around, and then I will have one side of it done, and then I'll switch over to the other side and then go the other direction and have that side done, and then I'll be able to start doing some of the actual milling out to get through the hollow itself. So what I need to do now is get this here moved over the dimensions I'm looking for to get that ready for here. Okay, now here's something interesting to think about. I could get my CAD program if I wanted to, and I could just figure out this dimension that I need to get to keep this 1/8 inch rim all the way around. But I don't want to use my CAD right now. I don't have it available right now to use right now. It's in the other room. So what I'm going to do is I want to figure out how I'm going to establish an 1/8 inch rim whenever I'm going to be moving my axes of my table over. Because watch this. Right now, on the center of this here, I can come over on the quadrant here, and I can edge find and come over that 1/8 inch that I need to get this rim line, alright? But the moment I move my table axis on the Y this direction, the rim dimension begins to get smaller, okay? So I can't move my table over and then just keep on moving the same amount that I would if I'm down here in the center, because it keeps on getting smaller due to the fact that it's getting closer to the center, as you can see there now. I can do angular measurements, calculations, and all that kind of stuff, but instead of going through all those calculations and everything, a simple way for me to do this would be just to make a visual. Since I have this on center right now, I can come over and come over that 1/8 inch in from the edge here, and then just make run the rotary table around in a circle here, and just make a visual reference around here on the workpiece. And then I can just use it as a visual reference whenever I go to do my milling. And that's probably the best way to do it, would be to make a visual reference with a small bit, and just make a visual reference all the way around, and then take it from there. Okay, the major diameter here is 2.92. The radius here is 1.46. So if I come over 1.46 over here, that takes me to the edge here. If I subtract that 0.125, which is the width of the rim here, which puts me at 1/8 of an inch here, that would give me at 1.335 off the center here. So I move my table 1.335, and that should put me a pointer line right here where I need it. And I'm using one of my little Dremel V cutters here, and I'll use that to mark out on my workpiece. So I'm going to come over that 1.335. 5, 6, 7, 8, 9, 10, 100, 1, 2, 3, 135, 20, 30, 5. Alright, and we should have our 1/8 inch. As we bring this down, I'll make a little mark there and see if we're about 1/8 of an inch here. It might be a little hard to see on a camera, but it is, there it is, that is the 1/8 inch. 1/8 inch from the center here to the edge of the workpiece. So that does establish a good 1/8 inch ring there. So what I'll do, I'll take my table around here now and get that established. Okay, now I'll get back to 0 on my roller table here, and then I can start moving my table over and start doing my features here. Okay, now I can move my y-axis 0.331 inches, and that will get me right in this area here, and then I can move my x-axis to line it up with my bit to keep that rim mark. Okay, I still have an interior border to do here yet too, so I know how far to come back this way. And so after looking on my CAD program, I had to look this time to check the diameter here. And the diameter comes out to 1.31 thousandths, 1 inch 31 thousandths, and of course the radius would be 516 thousandths of an inch. And so that's what I'll do. I'll move over now 516 thousandths, and I'll make another visual reference. Set to 0. 1, 2, 3, 4, 510, 15, 16. Alright, lock table. And then I'll make a visual reference here on the interior. Okay, now we're ready to move the y-axis this direction here. That they're 331 thousandths to get us into this here area here, and then we'll just eyeball that up inside this here 1/8 inch reference we put on the workpiece. So I need 331 thousandths on my y-axis. 1, 2, 310, 20, 30. And 1, 331 thousandths. I lock it, that moves on me, so I've got to lock it here. Oh, get that here. Right there, lock it. Okay, now it's locked. Okay, so now I can eyeball this up when I get my bit in there to get my edge of my bit on the edge of that line there, that reference line. And then I'll know exactly where to drill at. And the same thing down here, a straight line shot down through here, and then we'll move it 90 degrees and do the same thing again for the other 4 quadrants. Okay, here we go. Here's a good explanation now, a good example of what we're talking about. Since I moved my y-axis this direction here now, if you look at where the bit's at, the center of the bit is that far off of the reference line now with respect to where we were at when we were in the center here. So you can see as the more I go up on the y-axis this way, the more this is going to go away from the reference line. So that's why I had to make this here reference line a visual line here to work with. So what I'll do now is I'll just move my x-axis until I get the edge of the drill bit right on the edge of that line there, and then I'll know where to drill that at. Okay, I set my dial on the x-axis back to 0 here. When I move this over and I get this bit over here, I want to see how much that moves to just out of a reference to see how much. So I'm going to move this over now. And that looks about right there. That looks like that should do it right there. And that's about 31 thousandths of an inch. So it looks like it's about a 32nd of an inch on the first move here so far. Okay, so now what I'll do is I'll go ahead and drill that, and I'm going to drill that to a depth of about a ½ inch so I can leave a 1/4 inch of thickness on the tabletop itself. Okay, I just drilled this spot right here now. If I rotate the table 90 degrees, I should be able to get this spot here. And every 90 degrees, keep on getting the same areas here on the same way. So that's what I'm going to do now here is rotate this 90 degrees. Let's go your direction. 10, 20, 30, 40, 60, 70, 80, 90 degrees, which is actually 270 going backwards. And that should now give me my 90 degrees from this hole here to here, which is now from here to here, and then just keep on doing that 2 more times, and then I'll move it back this direction here and do the same thing, and then move the whole y-axis back the other side then and do this and go the same way again. Okay, I just moved my x-axis 331 thousandths, so I'm back to 0 again, and I'm right back to my reference mark here again. And so now again in the other opposite direction here, continue on with another 331 thousandths. And we'll go from there. Okay, that establishes the first set of reference holes here. And that would be here, 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 and here. And next we need to do now is we need to get the other side here now. Come this way here, back over here, and back over here now, and then go the other direction so that we can get the other side of this here now. So what I got to do is I got to move my table now, that 331 thousandths to get me back on center here, and then move an additional 331 thousandths again to get me established over to here now. And then again we go our 90 degrees in the other direction. Since we took the time before to indicate the workpiece in on the center of the rotary table, it really paid off, because if you look at all the holes now, these are the holes on the exterior, they're all done. And all these holes are lining up right on the line of our center of our reference line. They're lining right up all the way around. And if it wasn't indicated in properly, that those holes would have jumped back and forth on each side of the line. But this way here, because we took the time to indicate that in, everything is lining up properly now. Okay, now it's time to get the interior holes drilled for these reference holes now.